Welcome everyone to the 2017 online information session for graduate programs in civil engineering at Johns Hopkins University. My name is Professor Michael Shields, and I'll be walking through the presentation today. I'm joined also by a group of graduate students, so I'll allow them to first go through and introduce themselves.
Hello, I am Anindya Bhaduri. I am a fourth-year graduate student in this department. Professor Laurie Graham Brady.
Hi, I'm Mikhail Asanov. I'm also fourth-year PhD student. I work with Professor
Julie Carroll, second-year PhD student with Professor Guest.
Hi, I'm Ramyani Sengupta. I'm a first-year MSc student, and I'm being advised by Professor Guest.
Thank you. I'm also joined by Lisa Wetzelberger, who is our student coordinator, and she'll be providing some valuable information about the application process and other things that can help the students who the prospective students who are looking to apply to the program. So I want to go through just very quickly what we're going to talk about today, and during this presentation we'll give a very brief overview of Johns Hopkins, the graduate programs at the university, in particular talking about the civil engineering program, go through some of the courses that we offer, the facilities that we have, graduate student life, so that the graduate students can chime in, what some of our students do after they graduate, and then we'll have an opportunity to answer questions from those of you who are joining us. So I want to mention that throughout the presentation, you are free to submit questions at any time, and you can do that through the text window at the bottom. You can submit them at any time during the presentation. Most likely we will come to a lot of the questions and answers toward the end of the presentation, although as I said, you're free to submit them at any time. I want to mention that this webinar is being recorded, so we will post a link to it on our website, and you will be free to view it at a later time at your discretion. And I also want to mention that Professor Moen, who would be joining us today, who is the director of our master's program, cannot be with us today because his wife is actually in labor now, so he is currently with her at the hospital. So with that, I guess we'll get started, and we will provide some information about the school. So Johns Hopkins University is a large research institution. In fact, Johns Hopkins has led U.S. higher education and research and development spending by a significant margin for many, many years. And a large proportion of that research is conducted at the two largest divisions of the university, those being the medical school, which I'm sure many are familiar with, as well as the applied physics laboratory. The civil engineering department is in the Whiting School of Engineering, which is one of the 9 divisions. The Whiting School of Engineering is a medium-sized engineering school relative to many of the other peer institutions. Where the university also has, I guess, 6 or 7 other divisions that I won't talk specifically about. The engineering school, the Whiting School of Engineering, is pretty much even between graduate and undergraduate students. So there's about 1,600 graduate students in the Whiting School of Engineering and 1,800 undergraduates. So again, that makes us somewhat unique in the sense that we're a very research intensive university, heavy on graduate student population. Many other schools will have a much larger proportion of undergraduates, and I think that's something that makes Johns Hopkins unique. We also have a large part-time graduate program, and a large proportion of that is through the Engineering for Professionals program, which again I won't talk too much about today. Within the Whiting School of Engineering, we have 9 PhD programs. Civil engineering is one of them. 13 master's programs. Again, civil engineering is one of them, and we also have a master's program through the Engineering for Professionals program, which is part of the Part 21 part-time and online programs. The Whiting School has 181 research and academic faculty, 31 research faculty specifically, as well as 32 teaching faculty and many associated research scientists. It's a dynamic university, very closely connected, it's a dynamic school of engineering, very closely connected to the School of Medicine, the Applied Physics Lab, and the other divisions that make up Johns Hopkins University. So the civil engineering department itself, we are in many ways an unconventional civil engineering department. We have, as I'll talk about, we have specific emphases that are somewhat unique to civil engineering. We're a relatively small department compared to some of our peers. We are 12 faculty in total with 4 lecturers and part-time faculty. We are about between 40 and 50 PhD students and 21 master's students at the moment. And just to give you a perspective of how that breaks down, we're about equally, we have about an equal number of graduate students as we do undergraduate students. And so we're relatively balanced and in line with the university as a whole in that regard. And it's again important to emphasize that we're a very highly collaborative department. So we have a lot of collaborations amongst ourselves. So many of the faculty collaborate within the department, but also we have a great number of external collaborators. And again, we collaborate a great deal with the Applied Physics Lab, with School of Medicine, as well as outside institutions. So other universities, including, a couple of them are listed here, but I personally have collaborators at University of Pittsburgh and Harvard and other places. So we do collaborate a great deal, and that's very much a part of the fabric of our department. We also have industry and government collaborators. We collaborate a great deal, for example, with the Army Research Lab and with the Office of Naval Research. Companies such as conventional civil engineering companies and structural engineering companies like SGH and Thornton Tomasetti, as well as companies like Pratt & Whitney and other companies like Westinghouse Electric Company. So we do a lot of work that is fundamental research, but with an eye on the applications. We have some interesting facilities that we'll talk about as well, and all of our PhD students are funded by a variety of external sources. Several of them are listed here: the National Science Foundation, through collaborations with Department of Defense, with companies and various other places. So I guess at this time I would like to give the students an opportunity to talk a little bit about the department from their perspective. So maybe we can just go along the line and have the students talk about their research advisor and maybe some of the collaborations and those sort of things that they have experienced. Anindya, you want to start?
Yeah, sure. So I guess regarding the department, it's what I like best about the department. It's a very close network of students where we kind of sit in. We have a common space for all of us where we are not kind of divided by individual research groups. So that helps us in a lot of mingling among each other and very closely bonded. And regarding my research, I'm working with Professor Laurie Graham Brady, field of, and also co-advised by Professor Shields. So I'm working in the field of uncertainty quantification, where you kind of deal with stochastic mechanics, for example, among a variety of problems we deal with. So, and also in our group, we also work with fracture mechanics involving ceramics and metals. So I guess it's a pretty diverse research that we do in our group specifically, and then I guess others can talk about their research.
So hi everyone. I'll chime in a little bit more about the academic side of things because I think, Hopkins, the Wine School of Engineering in general is very rich in resources. You can always take lots of courses from other departments and sort of supplement your own research and get more information that you need to make your research better. As far as research concerned, so our group, the guest group, we work in the field of topology optimization. And for us, the application side of things is very important. And so a lot of projects that we work on are application driven and sort of application driven in mind. And yeah. So, actually, I should mention, recently, for instance, we had a project with the Applied Physics Lab and we had to just develop a component for a satellite that's going to go into space next year. So that's actually very exciting.
Hi, so I work in the same group as Misha, and he mentioned we do topology optimization. I specifically work with nonlinear mechanics, and we actually have a project with the government of Qatar right now, which is really neat, about topology optimization of tall buildings. But I also just wanted to piggyback off of something Anindya said about the close-knit nature of the department, that because we all get to know each other, and it's a manageable size group of people, you get to know who's really good at what and what people are working on. And so when you have a question about a particular subject, you go, oh, I remember so-and-so talked about that. I bet they would be a good resource. And people are really, really willing to help. It's not competitive, cutthroat. It's really, really collaborative.
Hi. So I can't really talk about research yet because I'm a first-year MSc student here. But the most important thing that I like for the department is that I can take courses from departments other than civil engineering, right? Like in the first year itself, I have right now I'm taking courses from the applied math department as well, apart from courses right here. And also because since we are a really small group, we can spend time in our department. So we almost know everyone, and we know each other, and we can talk to anyone when we want. Like even with our TA, like Julia here is actually a TA for one of my courses, and like I know that I can just go up and talk to her whenever I want, even if it's not her office. Yeah, so that's what I like the most, and so everyone basically helps out whenever you want, and even my advisor and even professors who are not my advisors, I can just go up and talk to them.
Thank you all. So I want to talk a little bit more about some of the specifics of our PhD and master's programs. So the table that's shown on this slide gives a very rough overview of these programs. So we have three options. The PhD program is a combination of courses and research. In each of these programs, the base is 8 courses, and there's 8 courses that are required for graduation, unless you're a master's student who's doing a master's essay or doing research to accompany the master's degree, in which case that course load is reduced by 1 to facilitate the research that you'll perform. And so the PhD program, you take 8 courses. Typically those courses will be spread over the first 2 years of the program. And the program lasts approximately 5 years. There's no hard set timing on how long a PhD will take. Some may take 4 years, some may take 6. It all depends on the progress of the research and so on. There's also a couple of other requirements associated with the PhD. In the first year, all students take what's called the Department Qualifying Exam, or the DQE. The DQE is an oral exam that's given in January of the first year that covers general knowledge from basic undergraduate concepts relevant to civil engineering and civil engineering research in our department. After completion of the DQE, then a student will typically begin really getting into the research at that point. I should also mention that PhD students come into our program for, in most cases, the students come in without a pre-assigned research advisor. And what that allows us to do is bring in a pool of students, and each student then meets with the various faculty members in the department and tries to find what is the best fit for that student and how, you know, how can they achieve the goals that they want through the research program that's most appropriate for them, while at the same time bringing in students from a faculty perspective that are going to meet project goals and various research goals. Somewhere in the 3rd to 4th year, the student will take what's called the GBO, or the Graduate Board Oral Exam. Anindya just passed his last night, so congratulations, Anindya. And that exam is a more advanced oral exam that's given by a panel of five professors, 3 from inside the department and 2 outside the department. And that is intended to test the basic skills necessary to perform graduate research. And again, that's typically taken in the 3rd or 4th year in our department. And the final requirement is a PhD thesis defense, which is completed at the end of the term and puts together the total research that the student has performed in their time. We also, in terms of the masters I mentioned before, we have 2 master's options. We have a coursework only master's. The intention is that the students would complete that in 1 year, and in order to do that, it's 8 courses, typically 4 courses per semester, and oftentimes accompanied with some sort of an externship during the January intersession timing, to allow you to get out and gain some industry experience, make connections in industry, and potentially help with employment after graduation. The last option is the essay option for the master's, and that typically takes a little bit longer. The course load is somewhat lighter to facilitate the student's research, and that will happen if a student identifies a research advisor that they want to perform research with, perhaps as an opportunity to transition into a PhD, but not necessarily. It could just be an opportunity for them to perform some university research and work with a faculty member on a research project of their interest. So those are our programs at a very high level. Of course, we'll be willing to answer any questions you have at the end. This just gives you a sense of some of the courses that we offer in our department. On the left-hand side, you see the courses that are offered specifically by faculty in our department. So you see we have a wide range of courses ranging from structural analysis, probabilistic methods, which is the course that I teach, to structural fire engineering and natural disasters. We really offer a variety of courses that can appeal to different interests of students, and also that cover the 3 main areas of emphasis for our department. And I'll talk about those in just a moment. We also offer courses through the Engineering for Professionals program, which are shown on the right-hand side. Most of these, but not all of them, are offered online. And our graduate students are free to take these courses as well. So these are courses that if you see something that interests you in that specific area, then these are available as well. The department is located in Latrobe Hall on the Homewood campus of Johns Hopkins University. And within this building, we have a variety of research facilities that are both experimental and computational in nature. So we have the Thin-Walled Structures Lab, which is a large-scale testing laboratory for structural elements, particularly mostly cold-formed steel and some other structural elements. I'll maybe let Misha talk for a moment about some of the 3D printing capabilities and additive manufacturing type facilities that we offer.
Sure. Thank you, Professor. So Oftentimes in topology optimization, the algorithm creates a structure which can be difficult to manufacture using traditional techniques, and therefore additive manufacturing with its free-form capability seems to be a natural marriage between the two technologies. And so as a result, we use our 3D printer to manufacture some of the designs that we make. The technology that the printer utilizes is called stereolithography, but where basically there is a vat of liquid monomers, and there's a ultraviolet laser shining light onto this vat, and then the part gets built layer by layer. So that's pretty much it.
Thanks, Misha. A couple of other things that that we have in our facilities. We have a laser imperfection scanner, which you see here, which is actually a laser scanner that goes over a structural member to identify and provide the geometry of structural imperfections. And on the top right, you'll see we also have a thermomechanical chamber that some of my students use to perform experiments on, in particular, aluminum at high temperature. So we're doing controlled experiments of aluminum during a fire, for example. Another thing that we should highlight, which is not shown here, is the computational facilities. Many of the researchers in our department are computational in nature, so we develop computer models to solve advanced problems. And so we also have a department civil engineering computing cluster, as well as access to the Maryland Advanced Research Computing Center, or MARCI for short, which is a very large, massive computer, high-performance computing center that is shared between Johns Hopkins University and the University of Maryland. And finally, I want to highlight the opportunity for graduate students and researchers in our department to do outreach with various programs. So we oftentimes will bring, for example, high school students and undergraduates into our lab facilities, as well as reaching out to local Baltimore elementary schools and various programs like the Girl Scouts performing scientific STEM-related programs. So a lot of our graduate students participate in activities like that as well. So I mentioned that we have 3 research areas in our department. Those research areas are structures, which is conventional for many civil engineering departments. And we also have areas in mechanics of materials. So mechanics of materials looks at the mechanics associated particularly oftentimes with structural materials, but not necessarily structural materials, performing a lot of simulations and multi-scale modeling, so modeling the behavior of materials, for example, in extreme environments. And the final emphasis is the systems group, which focuses on infrastructure, healthcare, and other systems that are relevant to modern society and how they function. How do we optimize them? How do we enhance their performance? So through the systems track, we have a great deal of collaborations across the university, for example, through the medical school and the Bloomberg School of Health. The mechanics of materials and structures folks have a lot of collaborations, for example, with the Applied Physics Lab and many a Department of Defense and other organizations. Now, in terms of the breakdown of our faculty, I mentioned before that we're 12 faculty in total. And in general, each of the faculty will identify with a primary research area, one of these structures, mechanics of materials, or systems. But then we're very collaborative, and we also are interdisciplinary in the sense that our research crosses the boundaries of those 3 areas as well. So when it comes to the structures track, we have 3 primary faculty. Professor Ben Schaefer, who does a lot of work in thin-walled structures and cold-form steel structures. And Thomas Gurnay, who will be joining us in January as a new faculty member, who is a professor in structural fire engineering. So he's doing a lot of research and looking at the effects of fire on structures and how do we make our structures more resilient and more perform better during fire and during fire-related incidents. As well as Professor Sangri, who has an emphasis on bridge, who was a practicing bridge engineer and has an emphasis on bridge engineering and historic structures in particular. Our systems group is composed of Judy Mitrani-Reiser, who focuses a lot on resilience and community resilience post-disaster. So she does a lot of work after earthquakes, looking at how do hospital systems and infrastructure systems how are they maintained and how are they performing after a disaster. Professor Agusa, who looks a lot at system dynamics, so he looks at large, complex systems. He's been doing a lot of work, for example, with healthcare systems recently, and applying engineering principles and systems engineering principles to these very large, complex systems, and how do we assess their performance. And Professor Siddiqui, who works in equilibrium of complex systems and optimization of those systems, with an emphasis on energy systems, so energy networks and food networks and healthcare and those sort of complex systems. And our largest thrust area is in mechanics of materials, where we have 5 faculty members. Professor Somnath Ghosh, who focuses in multi-scale modeling, so modeling of materials from the nanoscale, looking at molecular dynamics, all the way through large-scale applications, and particularly failure of materials. Professor Graham Brady, who does work in probabilistic modeling of materials, and is Anindya Baduri's advisor. And she does a lot of work in characterizing random media and looking at the behavior of materials that have stochastic qualities to them. Professor Guest, who is the advisor for Misha and Julia, is a professor working in topology optimization. So topology optimization process from optimization of structures all the way to optimization of material microstructures. And I'm sure Julia and Misha can answer more questions to that if people have questions. Myself, I work in uncertainty quantification and doing stochastic simulations for problems in materials and structures, and particularly looking at how do we introduce uncertainty into computational modeling. And lastly, we have Professor Stavros Gaitanaros, who does work in architected materials and modeling and experiments of architected materials from foams to DNA microstructures. So that gives you a very high level perspective on who we are as a faculty. Many of our graduates go on to have very successful careers in academia, military, industry. We really send our graduates to many different places across the country and across the world. So this just gives you a cross-section of some of the places that our graduates have gone to work, whether it's PhDs who have entered academia and are now professors, or whether it's students who have gone on to government labs to do research in various labs around the country, from Sandia National Lab to the Naval Research Lab in DC, as well as sending many of our students to really exciting places in industry, whether it be SpaceX, working on next generation of spacecraft, or civil engineering design, or many of the other areas that you see here. And so I want to also emphasize that our student body is is very diverse in terms of international students, and there are many opportunities for international students after they complete their degree at Johns Hopkins, and also the opportunities that are available for the master's students are very good in terms of industry placement within really great companies throughout the country and throughout the world. So I want to hand it over to the students again to talk about their experiences here in Baltimore and living in Baltimore and going to graduate school in Baltimore, I know I can say a lot about living here as a professor, but I think that it would mean more coming from students and how it is to live and work here as a graduate student.
Well, I mean, to start with, I guess the essentials, right? So there are plenty of opportunities to rent places around campus. So the graduate school does not provide housing for the students, for the graduate students, but there are plenty of apartments that you can rent out in the immediate vicinity of around campus, which is essentially anywhere from 5 minutes to maybe 12, 13 minutes by foot from basically door to door, from your house to your office. Personally, I bike every day. I essentially bike all year round, unless it snows heavily, which it does once in maybe 2 years in Baltimore. But yeah, so that's, and also there are plenty of places you can go to eat and buy groceries. So it's quite a nice neighborhood.
Yeah, I guess, and the advantage of being at Hopkins is it's very near to downtown. You can just hop on a Charm City circulator, which is for free for all people residing in Baltimore, and you can just, it's a 20-minute bus ride to downtown, and there's the harbor over there, and there's the aquarium. So there are a lot of places to see also in Baltimore. So that's the advantage of living in a big city. That's, I guess, the best part about being at Hopkins.
Hopkins also runs shuttles to the other sort of facilities that are related to the university, some of which just so happen to be located in really cool neighborhoods. So you can take the Hopkins shuttle to the Peabody School, which is in a neighborhood called Mount Vernon, which is just like, there's neat restaurants, there's neat parks, there's just a lot of things people like to do around there. I personally actually live out in the suburbs, and I sometimes drive in and sometimes take the bus in. So there also is, the public transportation system. And it's about 15 minutes door to door by car, which is not so bad, and sometimes parking a little tricky, but it's okay. But yeah, there's always the bus as an option too, which goes right, Charles Street, which is a major street right near campus, has multiple bus lines that go different places.
We should probably also add that the university has a network of vans. I think they're called hop vans, and I believe there are 4 or so routes, and they're all colored with a different color, and they go around the neighborhood. And the good thing is that, let's say you don't have a bicycle or a car, so let's say you can take that shuttle from university to Giant, so you can get your groceries, come back, and that's just really convenient. And a lot of people take advantage of that.
You can also take the College Town shuttle, because it kind of connects all the colleges right next to Hopkins, and you can go up to Towson and come back using it. It's also free for all students here. So.
Yep.
Yeah, it goes among, I think there's 5 colleges and
yeah,
universities.
I think it connects JHU with Loyola and University of Maryland, Towson University. So yeah,
and Morgan State. Yeah, there's a bunch of colleges and universities. So there's a free, during the academic year, it doesn't run during the summer, there's a free shuttle that's every half hour or hour or something like that just makes a loop among those universities, which again, also some of them just happen to be in cool places that you might want to go. So even if you have no reason to go to another university, you might want to go to the neighborhood where it is.
Right. And there are also a lot of resources for the students. For instance, Hopkins has a Makerspace. So actually, there are 2 3D printing facilities on campus. One of them is more research oriented. So essentially, if you have a project with your advisor, you go to that place. The building is called Wyman Park. It's not too far from here. And you get trained, and then you can come and use their industry-grade 3D printers to bring your sort of research from your computer to real life. And also there is a Makerspace, which is specifically for hobbyists. It's actually kind of funny. When you register for it, they specifically make sure you don't use that for research. And if you say, I'm going to use it for research, they return your application and tell you, please make sure you don't use it for research. Anyways, so that's a really cool space. They have they have a couple of 3D printers, a laser scanner, a bunch of other machines that you can use for really whatever you want. And I should add that they're currently in the process of building a new and expanded makerspace around the place called Our House. It's probably, I would say, 10 minutes by foot from campus. So we're very excited for that to come to life. So.
As you can see in the current slide.
A few words about Sega and some of the social side of being a graduate student in our department.
So like SEGA is our graduate student association. That's, you can say that's the first point of contact for an incoming student and introduction to all the existing students. It's kind of a very, again, a very close-knit organization. We don't have a lot of students, so it helps us in kind of interacting with all the current students. And since when I first came in, I guess SEGA helped me a lot to kind of get in sync with life at Hopkins in general. So I guess that's a kind of a blessing in disguise for all the incoming students. I guess you guys want to add more to it.
And we also have social events, like we have coffee hours, and like a few days ago we had the movie night. We all went up to watch Thor.
Yeah.
Yeah. And we also had Thanksgiving pizza night a few days ago, which was also sponsored by the GRO, I think. Yeah, which you can tell us a lot more about.
Yeah. Sure. So before I switch to GRO, in SEGA we also have 2 trips per year. So always a fall semester trip and a spring semester trip. As you can actually see on the top left corner, the fall 2016 we had a trip to Shenandoah National Park, and that was lots of fun. When the weather gets nicer, we also go to hikes around Baltimore. So we went to Washington Monument Hike, for instance. So it's a really nice organization, and we provide lots of resources for our civil engineering students. Now, I'm also a chair of the GRO, and GRO is a graduate representative organization, which is a student government for all students, almost all departments on Homewood campus. So if you're looking for some leadership opportunities, and as a graduate student, you can definitely join and do that. So we do a lot of those as well.
Yeah, I'm also involved with the Black Graduate Student Association, which is rekindling after several years of being defunct. So for right now, it's just a few sort of social events and whatnot, but also I'm also involved in a group called Women of Whiting, which is for female graduate students in all of STEM. It's not just the Whiting School, which does social events and also professional development events and outreach.
Thanks, guys. So I also want to mention that Johns Hopkins being located in Baltimore, we're about 45 minutes north of Washington, D.C. We're very conveniently located on the East Coast. It's only about 3 hours up to New York, a little further, 5 hours or so up to Boston. Philadelphia is not too far away, so it's very conveniently located for, if you may have family on the East Coast, or just for traveling up and down the coast and sort of seeing that part of the country. It's very conveniently located in that regard, and I actually myself have a lot of family in the New York and Connecticut area, so I go up there quite frequently, 6 times a year. So it's very centrally located in many regards, and has access to a lot of resources because of that. So I guess with that, we will start by answering some of the questions that have been submitted through the online Q&A portal. So I see a couple of them here that talk about different programs that are offered in civil engineering. Specifically, one related to building energy consumption modeling, and another related to environmental engineering. So I want to go back and talk a little bit along those lines about the specific programs that we offer. So energy is one of the focuses of our systems group. So Professor Siddiqui in particular does a great deal of work with energy models and energy economics and energy distribution systems and markets and those sort of things. So in terms of building energy consumption per se, I don't think we necessarily cover that niche in particular, but we do have a significant interest in energy resources and sustainability and optimization of energy systems. Now, in terms of environmental and water resources engineering, as another example from a question that has been posed, we have a separate environmental health and engineering department. So our department is not largely focused on environmental engineering, although we do have collaborations with some of those folks, and so there may be opportunities from that perspective. I want to take a minute. There are a couple of questions here related to funding, and whether funding is available for master's students and what funding opportunities are available for PhD students, and perhaps allow the students to chime in a little bit on that as well in terms of projects that they work on, and how you know, how funding is treated from the student's perspective. So for master students, they're oftentimes master students are not funded unless the student is performing some research with a faculty member and is supported by a research grant. So oftentimes master students will be self-funded or externally funded through some other scholarship, for example, from National Science Foundation or other programs that offer these sort of scholarships. PhD students are fully funded, and what that means is that when a cohort of PhD students comes in the first year, the PhD students are funded in full tuition, so the tuition is covered by the department in the first year, as well as a graduate student stipend, and we can provide more information on that through email and through the various other forums. So the students are provided with the tuition coverage and a stipend in the first year by the department, and then in subsequent years, the tuition and stipend are covered by the faculty member in a specific research program. So each of our students here are covered by different grants from their respective professors, and maybe they can talk a little bit about how that works from their perspective. So Anindya, for example, is funded by the Army Research Lab through the Materials and Extreme Dynamic Environments program. Maybe you can talk for a minute or two about that.
So I'm basically part of ME, which is the Hopkins Extreme Materials Institute. It's basically an institute within Hopkins, funded by ARL. So it was funded for a 10-year program. We recently finished it 5 years, and then we're on the second term, and that's how we're kind of getting. So we are a bunch of students at Hopkins and outside the institution, including universities like Rutgers, Caltech, I guess lots of others who are kind of funded for different tasks inside that institute, and all are funded by ARL. So I'm basically part of one specific group that works with composites. Yeah, so I'm part of that.
I mean, I can speak largely for our group as a whole. We get funding from different resources. One of the different ones is the National Science Foundation, which is some funding source for a lot of our graduate students, and also we get funded from specific companies that we work with, that we have projects with. For instance, in the past and still currently, we receive funding from United Technologies Research Center. We had a project with NASA, so one of our students who recently graduated, and she's now off working at the Skidmore, Owings and Merrill. She was receiving funding from NASA for her project. I would also like to add a bit on the funding aspect, because just to say that it's really enough, especially if you're a single student living by yourself. It's absolutely enough. You can find very affordable housing, very nice one too. And I mean, personally, I'm also able to save monthly for whatever future expense I decide that I have to spend that money on. But yeah, it's definitely, you definitely get enough money to make a good living.
Yeah, there are also some external funding sources like the National Science Foundation Graduate Research Fellowship Program, and there's some other programs. I'm mostly familiar with the ones that you have to be a U.S. citizen for. There's a lot through Department of Defense or NASA. other government organizations, but there are some that are privately funded, and you can be an international student as well. And the university will support your effort to apply for those. They'll write you letters of recommendation and help you with your application materials and whatnot. Mostly, in my experience, you sort of make an agreement with your advisor about whose responsibility it is, and most of what I've seen is the advisor sort of take that on themselves, and they work it out behind the scenes. They may talk to you about some of the details, but it's generally not your responsibility unless that's, and if it is, it would be explicitly communicated up front.
A few other questions that perhaps will be answered offline. I want to also mention that all of the questions that are submitted here, we will provide responses to them more formally offline as well. So the Q&A portion of this, you can also view that after the live session is completed, if you didn't have your question answered explicitly, for example. So one question that comes through here is, how important is research experience for PhD admissions? And I think that we can talk about a few things in terms of PhD admissions, because our admissions process may be a little bit different from some of the other PhD programs around the country. In particular, oftentimes students will apply for a master's program leading into a PhD, whereas in our department, students apply for the PhD program directly, which means that coming off of an undergraduate degree where you may or may not have any research experience, you will be applying directly for a PhD program. And so what that means is that you apply for the PhD program and you will earn a master's degree along the way. But if you're interested in the PhD, then that is the track to go for. And I would say that by no means is research experience as an undergraduate a necessity for admission into the PhD program. While the PhD program is a research, while a PhD is a research intensive degree, it is expected that the student would have a strong academic record coming in and would have strong recommendations from faculty members that taught them as an undergraduate and may know them personally. And beyond that, has strong test scores and the like. So those are really the things that we emphasize in our admissions process. We want to see someone who has the skills and the capabilities, but doesn't necessarily require the experience at the admissions stage. The experience will come through the PhD. I have a couple of questions about test scores and what are average test scores and minimum test scores. I'm gonna leave that for later to answer offline, because I don't have that data available to me right offhand, and answer maybe a couple of other questions about classes. For example, I know the students mentioned that you can take classes in other departments. So one question came through: is it possible to take classes, for example, in the School of Public Health or in the medical school? And I would actually say that we strongly encourage our students to take courses beyond civil engineering. While we offer a diverse program of courses, there are courses that can greatly enhance your experience and your research capabilities and what you're doing in your research that are outside of our department. So for example, I have a couple of students myself, a couple of PhD students who are earning master's degrees in applied mathematics. So they'll get a master's degree in applied mathematics and their PhD in civil engineering. And they do that because they're able to take courses outside of our department and supplement their education in our department with those courses. Professor Siddiqui and Professor Agusa, for example, will have students who take courses in the School of Public Health, for example. Let's see. So, what other questions? Are there any Latin American students currently in the department? We do have some Latin American students. I want to emphasize that our our department is a very diverse group. We have a very large international presence as well as some domestic students. So we have students really from all over the world. So Latin America, Europe, Asia, America. It really is a very, very diverse and very interesting group of people that I think really gives some a very unique cultural experience to being a graduate student here as well. Does students have anything they want to add to that?
I mean, it's true, we have a lot of international students and
Actually, more international students than domestic.
yeah.
By far.
So the American students may feel like a minority, which is, yeah. But that definitely contributes to our culture and social interactions and just makes the department that much more rich of a social environment. Diverse, yeah.
We learn a lot about each other.
Yeah, that's true.
We have heated debates.
But peaceful ones.
Of course. Constructive, respectful.
Yes, exactly.
Another question here about something I guess I talked a little bit about just a moment ago. Is it possible to do a double major or minor while doing a PhD in civil engineering? Typically, it's not common to do a quote-unquote double major in terms of having a PhD in multiple disciplines. Usually the PhD will be awarded in a discipline, although it is common for PhD students to have advisors in multiple departments. So I co-advise, for example, students in the material science and engineering department. While they're gaining a PhD in material science, I am also a co-advisor, so they're gaining insights from different fields. In terms of a quote-unquote minor, that again goes to the collaborative nature of the work that you're doing, as well as the opportunity that I mentioned before of potentially doing a master's degree, for example, in another field. Like I mentioned, I have students who are doing masters in applied mathematics and a PhD in civil engineering. So there are opportunities to have very diverse and collaborative research experiences. And in fact, I would say that's probably, it would be the exception to the rule that you don't have some sort of collaboration and some sort of experience and take courses and do work outside of your direct discipline in civil engineering. Okay, I think I've covered most of the questions. I guess there's another question here about the statement of purpose, and particularly because the statement of purpose is an important part of the application to our program. And the intention, and this is just my perspective, but the intention of the statement of purpose is really to provide an opportunity and insight into what is motivating you as an applicant into the program to pursue your graduate studies at Johns Hopkins. Why is Johns Hopkins a good fit for you? Why are you personally interested in research in our program? And why are you interested in the degree that you're going after, whether it's a master's degree or a PhD? What is really the driver behind that? And what gives you the motivation to pursue that, and where do you want to take that? What direction do you ultimately see yourself going in with that degree and with that experience? So I hope that provides some insight into that question, and if there's additional insights that I can provide, I'd be happy to answer them by email.